All right, so in this video, I will show you how we can take the information given and write it in point slope form. So to begin with, the introduction to point slope looks like this: y minus y1 equals mx minus x1, where m is the slope of the line and x1 comma y1, which are right here, are the coordinates of one point on the line. So a quick refresher before we start with examples. Remember, when it comes to slope and lines, we have 4 different cases that are connecting slope and line. If the slope is positive, the line is increasing from left to right. If the line is decreasing from left to right, the slope is negative. If the slope is 0, you're talking about a horizontal line. And if you have a vertical line, the slope is undefined. So don't forget those 4 cases that we have talked about before. So 4 different examples here. Let's start with the first one. Let's say, for example, that they're giving you the slope to be negative 1/3, and they're giving you the b-value, that the line is passing from the origin. So in order for you to take that information and put in point slope, you really need, as the name says it, at one point in the slope of the line. You do have the slope and you have the b, so do you really have a point? That's the question. The answer is yes, because b being 0 gives you really a point automatically. b0 means that the x is always 0, because b is on the y-axis, where x is 0, because you don't go left or right. And because b is 0, that would be your y value also. So if I take them, label them, and I put them in point slope, I have this: y minus 0, because that's your y1, equals m x minus x1. If I clean this up, because I have a bunch of zeros here, I will have negative 1/3 x. So even though it looks like slope-intercept, it is a deep point slope because my line is passing from the origin. That is one possible example you can have. You can have the b value and the m, and you're going to be asked to put it in point slope. Let's go to another example here. What about if you're given the slope and a random point of the line? So not the b, but a random point. Here's your slope, and a random point would be negative 6,8. Labeling would be very handy and important. I'm reminding you, you're replacing or you're substituting in the general formula that goes like this: y minus y1 equals m x minus x1. So I'm starting my substitution. Y minus, my y1 is 8, equals m, my m is a half, parentheses, x minus from the formula, and then I see that x1 is already a negative, so I'm going to put another parenthesis there. I can clean that up a little bit. Y minus 8, I don't like having 2 signs, and in the parentheses, a negative times a negative is positive. Now be careful and remember that if they ask you in the directions to put that information in point slope, you really have to stop here. This is point slope. If you move on and you solve for slope-intercept, you're missing the idea because they ask you for point slope, so be careful with that concept. Let's go to another example. What about if they give you 2 random points on the line? Here's that, and here's that. Now, in order for you to put from that information to come to point slope, you really need m and b. Well, first of all, you don't have the slope, but you have that information. You have 2 points. So let's label our points to start finding a slope. I'm reminding you, slope formula is y2 minus y1 over x2 minus x1. So if I substitute, I have y2 is 4, y1 is negative 2, my x2 is 3, and my x1 is 0. If I clean that up on the top, I have 4 plus 2, which is 6, over 3, and that is 2. So my slope is 2. Now, I need a point on the line. I'm really given 2 points. So in this specific scenario, I can really put down 2 possible answers. If I use the first order pair, my equation in point slope would be like this: y minus my y1 is negative 2 equals slope x minus x1, which is 0, because that is really the y-intercept. If I clean that up, I'm getting y plus 2 equals 2. You can leave it like that so they can clearly see the x1, or you can clean it up if you want to. It's up to you. But if they ask you for point slope, you really have to stop here. Or let's say you want to use the other order pair, this one to be the x1 and this to be your y1. So the other possibility you have is y minus the y1 is 4, right here, equals same slope, because you're talking about the same line, x minus the x1 is 3. And because I told you point slope, you stop right here. So these two equations that have boxed, they're both fine. And if they're not giving you a restriction as to what point you need to use, you're really allowed to use any point that you want to when you're ready to write down your final answer. All right, fourth scenario you can have, maybe you're given a graph. So let me try to make here a little graph. All right, so my line is passing from, let me do my line to be different color. Right here is one point, and the other point would be right here. So this point is 1, -2, and this point would be 0, 1. All right, let me connect the dots to make the line. So in order for me to write the equation in point slope, well, I really need the slope first. So I can use the slope triangle. From here to here, I'm going down 1, 2, 3 units, and to the right 1. So here's what I said, down 3 to the right 1. So the slope is -3, which I expect to be negative because the line is decreasing. Again, similar to before, I have two options of writing the equation in point slope because I really have 2 points. If I use the first point, which is the y-intercept, here's what I have. Y minus 1 equals slope x minus 0. And I need to stop here. I'm not distributing if they're asking for point slope. Or I can write the point slope by using the second point. So that's going to be y minus -2 equals same slope x minus 1. And there you have it.